This presentation is about cardiovascular disease-related abnormalities identifiable using an ECG, where we will discuss what an ECG is, how to interpret it, how to approach it, as well as the differences between normal and abnormal ECGs. An electrocardiogram is a recording of electrical potentials generated specifically by the heart. This test checks for problems with the activity of the heart, where we get to see the depolarization as well as repolarization of the heart. A basic ECG has the following: a P wave, a QRS complex, as well as a T wave. The P wave tells us about atrial depolarization, the QRS complex tells us about ventricular depolarization, and the T wave tells us about ventricular repolarization. We also notice a PR segment, ST segment, PR interval, as well as QT interval. When approaching an ECG, one first needs to look at the standardized block. Is it upright and is it straight? Then you move on to standard lead 2, where you look for a P wave in front of each QRS complex at constant distances. Then you move on to the AVR and we check if everything is negative. And lastly, you go to the V1 fixed block and check if you have a small r deep S. Then you go to V6 and you make sure that you only have an R wave present, and also you check for your ST segments whether the ST segment is in line with your PR segment, if the ST segment is elevated or the ST segment is depressed. Then you are able to measure the heart rate, which will tell you about bradycardia or tachycardia or a normal heart rate. Then from the PR interval, you can count the number of small blocks, which can tell you about a short circuit or heart block. And from the QRS complex, you can get information about a final branch block. And this is an image showing the normal ECG. You can see in AVR everything is negative. You find a normal V1 phase as well as a normal V6 phase. Standard lead 2, you have a P wave in front of each QRS complex at constant distances. This is normal. The abnormalities one can find in an ECG, we will discuss bradycardia, tachycardia, STEMI, non-STEMI, right bundle branch block, left bundle branch block, as well as left ventricular hypertrophy. Tachycardia is when you have a heart rate of more than 100 beats per minute. The causes could be sympathetic stimulation, fever, hyperthyroidism, acute blood loss, as well as stress or anxiety. Bradycardia, on the other hand, is if you have a pulse rate of less than 60 beats per minute, with the causes being hypothyroidism. Very fit athletes also present with bradycardia, which is normal, aging, as well as heart disease. A non-STEMI pattern is when you have a depression on the ST segment. This is generated by ischemia of the ventricles. Not only does it affect the ST segment, but it also affects the T wave, and you get a subendocardial lesion and end arteries, which are no collateral arteries. A STEMI pattern, on the other hand, is when you have an elevation on the ST segment. This is when you have a complete occlusion of the arteries. In a left bundle branch block, one notices a broad QRS complex, as well as the absence of Q waves in leads 1, V5, and V6, and also one notices big S waves from V1 to V3. The prevalence in males, you get a 0.43%, females 0.28%. Risk factors include age, blood pressure, as well as heart disease. Prevention is controlling the blood pressure as well as managing an underlying heart disease. A right bundle branch block is picked up using the V1 phase. If it is abnormal, then one can assume a right bundle branch block. Alternatively, one can look at the broadness of the QRS complex. The prevalence is 0.1 and 0.8 in the in the general population. Risk factors being increasing age, underlying heart diseases, as well as increased blood pressure. Prevention includes blood pressure control as well as managing left ventricular hypertrophy picked up using the R waves in your AVL segments where there are more than 12 blocks, or alternatively you can use the SMB1 as well as the RNV5 or 6, and if they are more than 37 blocks, you have left ventricular hypertrophy. The prevalence in women it's 19%, in men it's 16%. Risk factors include high blood pressure, obesity, and age. Prevention includes weight reduction as well as blood pressure control. There are policies that have been put in place, and these policies include the likes of salt reduction, which we know is linked to hypertension, which in turn contributes to 50% of the cardiovascular diseases. The references used in the slide are as follows. Thank you.